Well, all I can say is this might get interesting. I'm going to try to do a Hess's problem on a Word document so I can make a video to kind of help you guys out in terms of how to work this problem. This is number 72 on page 279 out of the textbook, and it is a doozy. This is one of the harder Hess's law problems that you're probably going to see. Okay, so the reaction that we're aiming for is this one in bold at the top, and then the four parts or the four reactions we're trying to combine to make that one are listed below, okay? And my suggestion to you when working these Hess's Law problems is to try and be systematic, okay? Process of elimination, if you will. So I'm going to look at each of these substances and the overall reaction one by one and see if I can find them in these reactions below in the places that I need them and in the quantities that I need them in. So the first one I see here is N2H4. And so I'm looking for N2H4, preferably as a reactant, but we can fix it if it isn't. And what I find is I find N2H4 as a product in both reactions 2 and 3. So rather than flip either one of those, I'm actually not going to address that. I'm going to, instead of manipulating one and I'm not sure what's going on, I'm actually going to move to the second substance and see if I can't find that sitting by itself somewhere. And unfortunately, what I find is O2, the next one I need, I have in both reactions 3 and 4. And even though these add up to what I need, I'm not sure that those reactions need to stay the way they're written. So again, I'm going to move to the next substance. And with this one, we get a winner. Because if you look, nitrogen only exists in reaction 1. And it is a product, and that's what I need. The only problem is this step has 4 nitrogens and I only need 1. But that's okay, because what we do is we're going to take this entire reaction and we're going to divide all of it by 4. Okay, so that means I'm going to take the energy and I'm going to divide it by 4. And that means I'm going to take each of these coefficients and divide them by 4. So I'm going to have 2/4 or 1/2 NH3, ammonia. I'm going to divide this by 4. And then I'm going to make this a 1, right? And then this one 3/4. Okay? All right. So this, and I'm going to highlight it because I've got nitrogen right where I want it. And that means this entire reaction, okay, reaction 1 cannot be moved. It's locked into place. I've got this one right where I want it, and it's the only one that has nitrogen. So we know that this one is correct the way it's written. All right, so then we go to the last substance here, and it's water. And unfortunately, this one's even worse because we see water in every single equation, every single reaction. Now, you could kind of look back at all 4 of these reactions and kind of try and strategize how to line some of these up because I know we see oxygen in both these and we see water in both of these. But I would encourage you, because this reaction is locked in and this is the only, nitrogen is the only one that we're actually using, what it means is the rest of these substances, we have to get rid of them. They have to be crossed out. So what we might want to do then, for instance, since I know I want to get rid of ammonia here, NH3, is see which other reaction has ammonia in it, and manipulate it to the point where I can get rid of this. I want to cross it out, okay? And if we look, ammonia is only in this reaction, in reaction number 3, but it's listed as a reactant. So what we need to do is not only flip this reaction, but if you see, ammonia is a 2 here, and I have 1/2 up here. So not only do I need to flip it, I also need to divide it by 4. So here's what I'm going to do. I'm going to real quickly here, I'm going to switch these 2 around. Okay, put this on one side of the arrow, do a little cut and paste here. All right, so I've got this switched around. That also means that this has to change signs. So I'm going to delete that negative sign because I flipped it. So it changes signs. And now I've got ammonia, if you look, as a product, and that's the way I want it, so I can cross it out. But again, we have to make sure the quantities are the same. So this is 2/4. I want this to be 1/4. I want this to be 1/4. And this is going to be 2/4. And this one, 1/4 of that would be 1/8. Okay, and let's not forget, the energy also needs to be divided by 4. Okay, all right. So now this reaction is also locked into place. And maybe to mark that, just so everybody knows and doesn't get confused, maybe I will highlight the energies there. So you know that you don't forget that these two reactions are absolutely locked into place. They can no longer be manipulated. So we get what we want. We highlight this. I'm going to highlight it in red because it's being crossed out. Okay, so we got rid of our ammonia. And so the next thing to look at is, again, systematically, the next substance I need to get rid of in this locked-in equation is N2O. And I'm lucky here because N2O exists only in reaction 2. Again, but it's as a reactant, so I need to make it a product. So I'm going to do something similar to 2 that I did to 3. I'm going to reverse the reaction, change the sign. And if you look, I have 3/4 N2O and only 1 N2O here. So I'm going to multiply this whole equation by 3/4. All right, so I'm going to reverse it. Again, a little cut and paste. I don't know what I just did. Hang on a second. There we go. I got rid of the arrow. It confused me. Get rid of that. Put this on this side. I've reversed those two. So that means I'm erasing now. If you look at my cursor, I'm getting rid of that negative sign. Okay, now I've got it where I want it. I've got N2O as a product right here. But again, we need to make sure those quantities match. So I'm going to multiply this whole thing by 3/4. So I have 3/4 that. 3/4 water. 3/4 N2O. And 3/4 times 3 would be 9/4. 9/4 hydrogen. There. 3 times 3/4. And of course, don't forget the energy then needs to be multiplied by 3/4. Okay, so again, this is now locked into place. So I'm going to highlight it. You know that this is where it needs to be. My N2O, I now have 3/4 N2O on both the reactant and the product side. So I'm going to cross those out. So things are looking pretty good. My water, I have 3/4 water here. It just so happens, and I know I got to get rid of it, and there's 3/4 water here in reaction number 2. So I'm going to just go ahead and cross those two out because I know they have to anyway, because neither one of them, or they're on either side of the equation, and these reactions are both locked in. So I'm going to go ahead and highlight those two. So it's always better to clear the board as much as we can. Okay? All right, let's see if we can clear up anything else. Now that we have all 3 of these locked in, I see N2H4. One of those is right here. You see that in reaction 2. There's 3/4 N2H4 there. And add that to 1/4 N2H4 there, adds up to 1, which is equal to the 1 N2H4 that we need at the top of the reaction. So again, I needed 1. There was 3/4 here, 1/4 here. Together, that's 1 N2H4. So that's lined up. And let's see if there's anything else. Well, I know I need 2 waters eventually as products, and I need some oxygen as a reactant. And nothing else in my locked-in area is really going to help me out too much. So that means it's all up to reaction number 4. And reaction number 4 is going to have to help me out here because I look up here in reaction number 2, I haven't gotten rid of that 9/4 hydrogen, and I need to get rid of that. And hydrogen is only located in another place in reaction 4. So that means reaction 4, as oddly as it sounds, needs to be multiplied by 9/4. Okay, it's as a reactant as I need it to be, but I need to multiply this whole thing by 9/4 in order to cross that out. So I'm going to multiply my energy by 9/4. and I'm going to go through here and put 9/4 H2. 9/4 times a half is 9/8 oxygen, 9/4 hydrogen, or sorry, water. And let me move my energy over here. Now they're all 4 locked in. So really all we have to do here is make sure everything is adding up the way it's supposed to be. Okay, and if I look, I have 9/8 oxygen here and 1/8 oxygen here. So 9/8 is really 1 and 1/8. I hope that makes sense. So 1/8 of this oxygen is going to cross out with the 1/8 oxygen there. The 1 oxygen is going to provide the oxygen I need for the overall reaction at the top. So again, out of the 9/8 here, 1 oxygen is used for the overall reaction. The remaining 1/8 crosses out in reaction number 3. The same thing's going to happen with my 9/4 hydrogen, except I want that to be red. Okay, so I want that to cross out with this. And the last thing left is 1/4 water as a reactant and 9/4 water as a product. In my overall reaction, I need 2 waters. So again, if we look at 9/4, that's really 2 and 1/4 water. 1/4 of that water is going to cross out with the 1/4 water on reaction 3. And the 2 waters that are left, okay, these 2 waters, trying to keep up here, these 2 waters right here in the 4th reaction ends up being the 2 waters we need in the overall. So now we've got everything lined up the way we need to. Everything is mathematically sound. What we need to do then is take all of those energies, now that everything's lined up, is sum these enthalpies. I don't know if, and I'm not sure how we spell enthalpies. I don't know if it's I-E-S or Y-S. Anyway, sum these all up, okay? And that should give you the right answer, okay? I hope this has been helpful. And if you come across another problem like this, I don't know how much time I'll be able to make a bunch of these, but if you find this helpful, please let me know, and I will try and make some more of them as we need them, okay? Hope you have a good afternoon. See you tomorrow.